projectiles in 2 dimensions. Example 2. So we have a ball that's projected at an angle of 60 degrees above the horizontal with an initial velocity of 10 meters per second, and it lands on a horizontal surface which is 18 meters below where it took off from. So the vertical displacement here initially was 0. I'm taking anything in the upwards direction as positive. So 0 displacement, positive displacement, maximum displacement, maximum height reached. The ball is falling, the displacement is decreasing, it's still positive. The displacement here is 0, it's level with where it started with vertically. And now anything below this line, the displacement is now negative until it hits the ground here, where the displacement is now minus 18 meters. So considering vertical motion, positive direction, SY, minus 18 meters, initial vertical velocity, so 10 sine 60 simplifies to 5√3 meters per second. We're not interested in the vertical velocity component here, so I've crossed that one out. The acceleration in the vertical direction, minus g, and we're after t. So Subat formulae, the one without v, because we've crossed out v, s equals ut plus half at squared, and then we just substitute the values in, and we've got 2 values for t. 2.99 seconds, that's the one we're looking for. T equals minus 1.22 seconds is a nonsense, we discard it. Again, use subscript notation here, but it's not necessary at this stage. Example 3. So the initial velocity of the ball here is 25 meters per second at an angle theta to the horizontal. The angle is not given directly, but it's given in this form. Tan theta equals 5/2. So we're given the tan ratio. So horizontally we have 25 cos theta, because that's the adjacent side to the angle, and vertically 25 sine theta, it's the opposite side. Again, check the direction of the arrows in your triangle. So the black arrow takes us from here, starting point, ending point here. And if we follow the blue and red arrows, we should start and end at the same place. So start here, along here, and then straight up. So they are pointing in the correct direction. So we have the horizontal velocity component, ux, and the vertical velocity component, uy. And from the ratio, we do a right angle triangle. So there's theta, opposite, adjacent. Pythagoras' theorem gives us root 29 for the longest side, which will give us these 2 ratios for sine and cos. For example, sine is the opposite over the hypotenuse, so 5/√29. Okay, so for the horizontal component we have 25 cos theta, but cos theta is 2/√29, so I can replace all of this with 2/√29, and we can do something similar here. So now we have these, and we can simplify. These are the exact values so far. If we want the rounded values, we will have these. And I've used 4 significant figures here, so if we use these in further calculations, we're not losing accuracy. There's nothing more on this example.